Hello, dear students. In this video, we are going to see about word embedding, and we are going to see what is word embedding, and we are going to say how we are going to do the word embedding using Word2vec model. So, if you speak about what is word embedding means, actually, we know that in NLP is actually we want to make a machine to understand the human language. That's what NLP. So it's all about so many text information, right? So we know that generally computer can understand only numbers. So what we are going to do in word embedding for the words, we are going to give some numbers in terms of vectors. What is vector means? Set of numbers, we call it as set of numbers or vectors. So for every word or every vocabulary means the unique word in the corpus, right? So every word we are going to give a vector. So what is a vector? It's a set of numbers which will be a meaningful set of numbers given to each and every word. So when we give a meaningful number to a word by which we can able to do some mathematics over the word. So that is what word embedding. So when we give a number, which means in terms of vectors. Vectors means set of numbers representing many features about the word. So when we give a word a vector through which we can able to do some mathematics over the word. So that is what word embedding. Word embedding means for a word we are going to give assign a vector. So what kind of mathematics we can do? This is an example. Car minus bike it will be giving a truck. So this kind of mathematics we can do. Car minus bike plus bus will be a truck. So we'll see how this can be possible and how we can do mathematics when we give word embedding. Let's see then example. So let us see. For example, if there are some words here, I have taken some words like car, bike, bus. So when I do this mathematical operations, it's going to be giving a truck. So how does it happens is, as I told you, for every word, we will be assigning a vector. Vector means it's a set of numbers. So how will we give this vector means we are going to get some of the features about the car, the word car, and we are going to assign some numbers to it. So set of number become a vector. So let's see for a car, how can we assign a number? Let me take some of the features about car. Let's talk about wheel, engine, speed, and public transport. So car has four wheels, there's one engine, speed is high, so and public transport is not. It's not, car is not a public transport, so I assign 0. So what is the vector? I have taken only 4 features here, and we have 4 set of numbers in this vector. So the number I assign to car is 4110. Similarly, let's take bike. Bike, if I say take the same features, wheel is 2 wheels, engine 0, speed, I have given the speed as 0.7, and the public transport is bike is not a public transport. So what is the vector assigned to this bike is 20, which means vehicle wheel is 2, engine is 0, speed is 0.7, and public transport is 0. So this is the vector assigned to bike. Similarly, for the bus, this is the feature, and this is the vector assigned to it. So bus means it has 6 wheels, maybe engine is there, speed maybe like this. It's a public transport, so it is 1. So this is the vector I have assigned to this word bus. Right? So now we got the numbers, numerical form of this word. Now we can do some mathematical operations. So what is the thing we have said? Car minus bike plus bus. So let's say car minus bike. So when you do the operation, this is the vector for car and this is the vector for bike. And so when I do the minus, 4 minus 2 is 2. 1 minus 0 is 1. 1 minus 0.7 is 0.3 and 0 minus 0 is 0. So when I say car minus bike, I got the vector value as this. right? This is the vector value I got. Similarly, along with this car minus bike, I'm going to add bus. So what is the vector for bus? This is the vector for bus, 6, 1, 0.6 and 1. So now when I add, I got another number. So this number is the vector I got for as a result of this operation. So now if you check this, we can see this vector I got out of this. No, this vector is a value of a truck. So if you see a truck, if you consider the features like wheel, I have 8, engine is 2, speed is 0.9, public transport is 1. So this is an example, okay? So hand coded example I can say. So I have hand coded it by taking all these features. I have assigned some values. So this value, see, I'm getting for this mathematical operation, I'm getting the answer is 8 to 0.91. Same answer I got for truck. So car minus bike plus bus is truck. So I could able to perform some mathematical operations over this words, right? How I can do it? Because of this word embedding. How I can do this word embedding? Because I gave some numerical representation for every word so that I can able to do some mathematics over it and I'm getting a result. Since computer can also understand only numbers. So here is another example. Horse minus deer plus wolf equal to dog. So for in this context, I can take different features. For horse, I can take legs, how many legs, it is domesticated, what is its speed, is it a carnivorous or not. So based on that, I'm assigning a value by which I got a vector for horse. Similarly, I got a vector for deer and I got a wolf. So when I do this mathematical operation, horse minus deer, I got this value, which means I'm removing the wild nature of the deer and I'm keeping only the domesticated characteristics. So I got a vector over here, and when I add the wolf with this, I got a vector value. So this vector value is the vector value of dog. So what I got, see, same value 4, 1, 0.8 and 1. So this is the same value I get for dog. So when I do the mathematical operation, I'm getting another value, right? So this is what called as word embedding. Okay, so let's take similarly, we can do it for anything. Here in the case of laptop, desktop, so these are the words. We can take some features of all this by which I can get a vector for this and I can do some mathematical operation, I'll get it. But this for little words, so little vocabularies, and considering only very few features, I can able to hand code the vectors like this. But in real life, we cannot do this hand coding, right? Because it has in the corpus, with the word corpus, maybe having a huge number of words. For example, let us take Wikipedia. How many number of words will be there? So for everything, in all contexts, I cannot set a feature for it and I cannot give a vector. For example, here I have considered 4 or 5 features for every particular word. But in real life, we cannot assume all kind of feature for a word. So in this context, we can bring neural network. Hope you might have learned neural network in machine learning and how does it operates. So the neural network will be doing all this operation. It automatically find the features and then it will assign the vector for all the words in the corpus or in the word corpus, and by which when we do some word prediction based on the neural network, we could able to find the next word, or we can able to predict the new word based on the given word. So the given word, we can say the context. Based on the context, we could able to predict the new word, or we can filling the word. So this is, say, for example, it's another example. I have given a story context here. There was a famous footballer known for his incredible dribbling and goal scoring ability. Likewise, I have a sentence. So what neural network can do, by seeing all these words, it will do some neural networking. So we know that it has an input layer. So it will take all the unique features of this word. For example, what are the unique features means like unique words, okay, by which I can take the input layers. So what are the unique words? There was. So this are all the unique words, right, from all this. So for this, for example, in machine learning, you might have learned about one hot encoding, because we cannot do any mathematical operation using categorical data. We want to convert the categorical data to numerical data. For that, we use one hot encoding. So similarly, if I am considering, I have 15, let us consider there are 15 unique words here. Okay, so what happens? So there will be given word of one. All the rest of other unique words will be assigned 0. And then was. So first is given for there. So for was, it is not there. So it is 0. For was, I am giving the word as 1. The rest of all are 0. Let us consider there is 15 unique words. Similarly, the first two is given for there and for was. And for A, I'll give 0, 0, and this word as 1, and the rest of all as 0. So this is the one hot representation for there. And for was, this is the one hot representation encoding. And for A, this is the one hot representation or one hot encoding. For famous, how we do 0, 0, 0, and 1. Likewise, for all the unique words, it will be giving some one hot encoding. Okay, one hot encoding will be given, and based on it, so these are all the input values we give to the neural network. And then the next layer for the neural network is hidden layer. So in the hidden layer, I can have any number of neurons, or the perceptrons I can have. That is also a hyperparameter. I can have any number of neurons in the hidden layer, or I can have any number of hidden layers also. In the hidden layer, I can decide how many neurons I have to keep. Based on that, it will be assigned the value. Hope you remember the back propagation we do in a neural network, feed forward and back propagation, and we can predict it. So in real life, automatically the neural network will be getting all this unique words, and it will finding the vector for it, and it will understand a suitable vector for every word, by which it could able to predict a new word. So here, for example, after it predict all the words, let me give a problem to it. Dash played in the field. So by this computation, mathematical operations using neural network, it could able to find footballer played in the finals, athlete played in the finals. Two option is there. So it could able to do some mathematical operations. So let us consider these are the features it may be considered: speed, stamina, skill, and competition. These are the vectors generated for footballer and athletics. Both are nearly similar. The similarity between the words can be found by many methods. Even we have Euclidean distance can be used, or cosine similarity can be used. By all these things, we can able to find the similarity between the words, and we can find the most suitable word for this context. So this footballer and the athlete are the target word, and this played in finals. This is the given word. So the given word is called as context. So in this particular context, what will be the word you can fill in this place? So that will be predicted. So because of this neural networks. So for example, for this given para. So these are the training samples it will be generating. How does it do the training sample means? Say for example, we can fix the a sliding window. So if I am taking the sliding window as 4, so it will take the 4 words. So if you see in this previous, there was a famous footballer. So there was a famous, so that footballer. So there was 4 words are taken into the sliding window. So this is the sample. So if there was a famous, what will be the next word? Footballer. And then it will take was a famous footballer. So what will be the next word? Was a famous footballer known? Is the target word. What is the context? What was a footballer? Since I have taken the window size as 4, it will take 4 words and it will train. So if this is the set of context word, so here you can see these are the context word, given context. So this is the given context. context. So this is the target word. So known as a target word. So based on this given context, what will be the next word? This is the target word. So a famous footballer known, what may be the next word? So like this, it will be generating so many training samples, and then it will train to find the next words. So likewise, in real life, it has a huge training sample, and it will keep aside so that it can able to find the best suitable word for this. Say, let's say example, Google developed, and it has many choice. That's last year. So chair is there. Google developed chair. Is it a suitable word? No. So based on this given context, Google developed dash last year. So what will be the most similar word here? AI. Google developed AI last year. So doctor diagnosed bicycle in the patient. So that will not be there, right? So what was the most suitable word? This can be coming there. The Egyptian built dash thousands of years ago. Laptop? That is not. So it will find the most suitable word or the target word which is having this minimal distance to this context, and then it will predict it. So here is another example. So already I have told how does it happens in the real world. So using one hot encoding, for example, if this is the sentence, it will pick up all the unique word, and by taking all the unique word, it will give it based on the one hot encoding, it will give you the values for all the words. That values we can call it as vectors. So for there was, so for there, this is the vector value. Was, this is the vector value. So you can see there, this is the one. And for was, this is the one. So likewise, for all the unique words, it will be giving a one-hot encoding. That will be its vector value may be considered. And then by this, it will do the mathematical operation. This is another example. So here also another example. So what? Let's take an example here. I will show a neural network model for it. So how does it happen? So here is there was a famous, and I have to predict what will be the next word. So here it is considered as four word window size is 4, which means 4 words will be taken as a context. And then it has to do the predictions. So how the neural network will be? So it will be like there was a famous. So we have input vector for it. So let's take two windows. So two window size. If 2 is a window size, so there for example, there for the word there, here we have 1, rest of all are 0. And then for was, how does the input will be? 0, 1, and rest of all are 0. Likewise, we will be giving the input, and all this input will be, this is the input layer, and this input layer will be connected to the hidden layer, which may be having any number of vectors. So so any number of neurons, or perceptron. So this number of perceptrons is a hyperparameter. We can adjust as we like. Okay. So likewise, all next word can be was A, right? So 0, 0, 1. Likewise, we'll be connecting all the inputs to this neurons, and this can also be connected to this. This can also be connected to this. So fully connected neural network. You may be knowing about this neural network already from the machine learning. So this is what my neural network for this. And then you know that for every connection, initially it will assign a random weight. Weight 1, weight 2, weight 3. So what does this weight says? How this value influence the output. So if this is how much it's going to influence this input, how much is going to influence the output is represented in the form of weight. So initially we don't know what will be the correct weight. So it will give you the random value as a weight. And after that, we know for every perceptron, 2 operation will be happening, right? One will be, it will be multiplying the input value with the weight, and it will sum all the values, and that value will be given to the activation layer, and activation layer will trigger the output, and we'll get a value here. So finally, we'll be getting an output layer. So every neurons will be performing this operations of summing of the values of input value into the weight, and we sum all and give the values to the activation layer, and the value will be triggered out of this perceptron, and this value will be given again here also summation, and the activation will be happening, and we'll get the output. So when we get the output, for example, I want to predict there was a famous, and I want the output as footballer. So here you will be getting a value. For example, footballer means, for example, I want to get a value of, for example, 0, 0, 0, 0, sorry, 0, 0, 1. This is what the value I want to predict here, 1. But this is what the value I want to predict, I want to get as an output. Okay, but in the first time, since we gave the weight as a random value, we may not be getting the exact output as footballer. So it may be giving some other value. Maybe instead of 1, it may be giving 2, 0.2 or some other value. So it will compare the this is the predicted value with the actual value. Actual value is 1. So it will find the difference, 0.2 minus 1. So the loss is 0.8. So based on this loss, it will go back. It will go back. So this is back propagation, right? Go back and update this weight. So and it will give you assign the new weight based on the loss. We have formula for it. And again, once again, it do the same operation. Again, it will do the feed forward. Again, it will check the predicted value with the actual value. So until the loss, the difference between actual value and the predicted value is less, this operations will be keep on repeated. So in a one stage, we'll get the correct output. So that weight will be assigned to all these words. So by that, the neural network will be trained, and finally we get the correct output. So this is what happens in the neural networks. So what is the purpose of neural network there? Earlier, we by hand coding or hand in my own hand coded, I gave a vector value for each and every word. But in real world, this is not possible. So with the help of neural network, we can able to assign the vector for this, and that vector value is done through the neural network. So we get this vector value through the network, and we train it, and finally we could able to do the prediction. So one of the word encoding model is Word2vec. So Word2vec means word to vector. So this is one of the example of word encoding. So how does this so I hope you got it. What is word encoding? For word encoding, we have an example, that is Word2vec. So this is how the Word2vec means. This is word encoding is the work of Word2vec. So Word2vec is also going to use the neural network approach, which I have explained. Same thing will happening here. We are not going to assign by hand. We are not going to assign the vectors for all the words. Instead, the neural network will find the suitable vector for all the words with the help of all the words. So that is one of the way Word2vec work. So this Word2vec have two architecture by which it is going to work. One is continuous bag of words. We call it a CBOW, C-B-O-W. That is continuous bag of words. What is bag of words? We have already learned. It's collection of words. It's a corpus, word corpus. So one approach, that is what bag of words. So one of the techniques we are going to use in Word2vec model of word encoding is continuous bag of word. What is happening? What will happen in the continuous word of bag means here the context word will be given as context word. The context word, no, this is context word will be given. We want to predict the target. So context will be given. This will be given, and we want to find the target. So that is continuous workout. For example, let us take a sentence. The cat sat on the mat. This is the given word. Okay, I want to predict what will come in this place. I'm going to make a blank place here. So I'll give the dash sat on the mat. So what is my context? So the input is the cat sat on the mat. So this is the dash. This word I want to predict. This is my target word. What are the context word? The, sat, on, the, mat. This is my context word. So based on the context word, I want to predict this target word, that is cat. So if this is the case, then it is called this technique is called as continuous bag of word. So this continuous word bag of word technique is faster, and it's worked very well with the small data set also, because we are going to give the context. Based on the context, we are going to predict the target. So this continuous bag of word technique is very well suitable for small data set, and it will be working very faster. Another techniques used in the Word2vec model is skip-gram model. What is the skip-gram model? It is the opposite of word. Here, the target word will be given. This is given. By the given target word, we have to predict what the context word. Context word we want to predict here. So that is the only difference. So in CBOW, that is continuous word of bag, continuous bag of word. What we did, the context word will be given, and we want to find the predicted word. Okay, the target word we want to predict. But in the skip-gram model, the target word will be given. Based on that, we want to predict the context word. That is the difference. So predict the context word. So here, cat is the target word. So cat will be given. So cat will be given, and we want to predict. We want to predict the context word. What are the context word? The, sat, on, the. So this is the context word. So this is what the other thing. So this work actually continuous bag of word is faster, and it's suitable for smaller data set. And this is suitable for the larger data set. If you have large data set, then only we can able to predict the context word when a target word is given. So this is what the example. So here context is given. Scientists discovered what will be the next word here? Scientists discovered a dash. So the next word I want to predict. So context is given. I want to predict the target. So the next word would be new, and next can be something else. So context is given, predict the target. So that is CBOW, continuous bag of word. And what? So here is, so to do this, again, we can go with a model, continuous, we will be given the context, right? So here also we can work with the window concept as I told earlier. So here the window can be 4. So I can take the context of this. So it will do the training by taking the context already. Based on that, so if the context length is 4, so it will for if I want to predict the target word as R, it will take the before 2 words and after 2 words. So, and again it will move the window. So to predict the word all, it take the previous 2 window and the next 2 words. Since I have taken the window size as 4, likewise it will do train, and finally it will be able to do the predictions. So this also I have explained the neural network. How does it happens? It takes every words, it vectors, and that will be connected to the hidden layer, which may be having any number of neurons. It's a hyperparameter we can adjust. Finally, we can able to predict the next word. So if there is a loss, then we can do the back propagation. I have already explained it. The second technique used already I have told you, skip-gram model. In the skip-gram model, target will be given. Here you can see the target is given here. Target is given here. Based on the target new, we have to predict the context word. So this is called as skip-gram model. So using these 2 techniques, what are 2 techniques for Word2vec? So one is continuous bag of word, another one is skip-gram model. Using this 2 technique, we can able to do word embedding, and we can able to predict the word. Either the word can be a target word or it can be a context word. I hope you got it. Thank you for listening. God bless you.